Okay, so we should be live now. Let me double check that this is correct. We should be live now. Yes, okay. 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 So hello, everybody again. We are even more in quarantine than we were last week. So we'll have a new seminar today. It's my pleasure to introduce Irene Amerini, who recently joined our department and who will be talking about strategies for countering fake information. So take it away.
Thank you, Roberto. Good afternoon, everybody. Today, I would like to talk to you about the strategies for countering fake information, and in particular about new finding and new trends in multimedia authenticity verification and source identification regarding image and video in particular. Especially, I would like to emphasize current methodologies employing artificial intelligence technique and deep learning methods to do this. A little bit, I'm sorry, I have, okay, now it's working. A little bit about me, as Roberto already said, I joined the Department of Computer Control and
Sorry, Irene.
Yes,
Just
Roberto, yes.
yes, just a second. It seems like your volume is coming through a little bit low.
Uh-huh.
Uh, I don't know whether there is anything you can do.
I don't know if I can manage because the microphone is the maximum level here. But I don't know. Maybe I can stop the video and go
Yeah.
uh, closer to the microphone. Let's see if it's working.
Okay. So noise in the background will go away as soon as I will mute myself. So that's not a problem, which will be soon. But the important thing is that you can hear her. Once that's fixed, then we'll.
Can you hear me a little bit better?
Uh,
Can you hear me
yes, yes, I can hear you. I don't know if they can.
better? Can I go?
I can.
Yes. Can I assume? Okay. Okay. Okay, a little bit about me. As already said, I joined in September 2019 the department in La Sapienza in Rome. Formerly, I was at the University of Florence at Media Integration and Communication Center, where I worked there as a postdoc and also as PhD student. I had also some experience and I research on the topic that I would like to talk to you today, that is multimedia forensic, also with two different research visits during my PhD in Binghamton University in US, and 2 years ago as visiting fellow at Charles Sturt University in Australia, where I was a recipient of Endeavour Fellowship there. The context where I'm working from a research point of view is weaponized information. What does it mean? It means the study of all the tactical and strategic use of information to gain an advantage. All the offensive strategies put in place to gain an advantage with respect to an enemy or an adversary in general. You can understand that the impact of fake information when we talk about weaponized information, when an information is used to harm a person, a country, an organization, it's really, really important. And also it's important to understand and analyze the organic propagation of this kind of misinformation. And in particular, images and video, directly more than other kind of media, inoculate messages and have strong impact on personal opinion, as you can understand very, very easily. In many, many different application scenarios. Like, for example, propaganda and military point of view. For example, a cyber terroristic scenario where images and video are used as propaganda. Or, for example, in a court of law, it's very important to understand if there is a misinformation in the media, because if an image or a video are used as evidence in a trial, we need to understand if this image or video are original or are somehow are manipulated. This is important many different application scenario. For example, in all this attack, like reputation attack, there is the image on the left, but maybe we can think to worst attack. For example, if you want to blackmail a key person of an organization or a country, I don't know, with pedopornography or pornography images, if you think about like this, you can understand how the reputation attack is really important to handle from a forensic point of view. On the other side, we have insurance fraud or document fraud, where we have an evidence alteration of an image or a video in order to alter the content. Or we can have also crime scene alteration, because when a policeman want to shoot some picture of a crime scene, sometimes this picture can be somehow manipulated and then reported in a trial with different content respect to the original one. But we don't only analyze images, but also video. Here I report a video that was shared on the social media during the terroristic attack in Brussels in 2016. But it came out that was a video that was taken at the train station in Moscow during an explosion in 2011. So we need to understand also not only if an image is manipulated or not, but also the context. We need to understand if the context is related to the content of an image. And here we have more recent news that we know everybody about this coronavirus. We are all at home for this reason. We have this here. There is this news about all the people that went to the train station in Milan to escape from the virus in Milan, to go down in the south to reach their family. But actually wasn't a real picture, but was a picture that was taken in 2017 during holiday vacation, Christmas vacation. So more than ever, it's important to understand what is the real and what is the fake in the news. But new forms of misinformation emerge. We need new ways to deal with them, especially regarding new technologies like deepfakes, where a realistic AI-generated video show real people doing and saying something that is not real, saying fictional things. So these kind of new technologies are rapidly evolving, and detecting them present a huge technical challenge. So in image and video forensic, now we need to deal also with this kind of misinformation. Here there is some example of deepfake. And what I would like to show you that there is some kind of application. Zao, for example, here for a smartphone application that is able to create fake video with only the use of our smartphone. So it's not, there is no need to have a great computer or big framework or big cloud computing, big power. Let me see. I'm sorry. Audio settings. Okay, I'm here. So where? Automatic adjust is disabled. Yes. It's really yes. It might be better, I don't know. But maybe it's more noisy. I don't know. Can you hear better now? Can you hear? I'm really sorry about this, but I don't know. I don't have any other microphone at home. I don't know how can we do this. No. Yeah.
Guys, I interrupted Irene because we were trying to solve the problem. So there is no connection problem. The only problem is that I asked her to just pause a second. You couldn't hear me probably because my audio was disabled on the stream. I asked her to double check the audio settings because there is some problem with the streaming. As you mentioned, the volume is coming uh, up and down. So I mean, it doesn't seem to be fixed with settings on Zoom. So let's just move on like this. And the problem again is you didn't hear anything because she wasn't saying anything. So
Okay, now no. Now I can speak, but with the adjustment on,
okay,
you can try.
yeah, let's try like this.
Okay. Okay. Okay, so we start again. If I can reach again the presentation, sorry. Okay. Okay. here there are a lot proliferation of images of deepfake or video on the web. So if you want to see videos on deepfake, you can go on YouTube and you can find all the video that you want. In particular, I would like to show. I can show you because you cannot hear the voice of this video, but briefly, this video is really interesting because there is this actor that was acting like Tom Cruise, and when he talked with his voice, the face of Tom Cruise came out instead of his face, and it's really well done. If you want to see him, to see this video, it's really interesting. This one is another example where it's very famous because there was this deep fake about Matteo Renzi on Striscia la Notizia in September. It's really interesting. Is not really well done as deep fake. You can spot the deep fake really quickly, but it's interesting because it was the first deep fake done in Italy and with a politician. So it's interesting from the point of view that I told you before about the weaponized information, the use of the image and the video as weapon. Okay, let's go further. The point is how we can secure an image or a video. How can we understand if an image is manipulated or not? There are different methods in literature. We can insert digital watermarking inside the image or encrypt some information in the image in order to understand if the watermark, for example, is broken and you cannot find again in the image the same watermark that was inserted, you can understand very easily that the image is not the original one, but is the manipulated one. Yeah. But you can hear
Too? Okay, so we have a question.
Roberto, can you hear me better?
Yeah, we can hear you better. So the question is more a comment. So Franco says, newspaper use stock photos all the time, which do not correspond necessarily to the current event. It's an old practice. How does this play here nowadays?
I'm sorry, now I cannot hear you.
Can you hear me?
So I can try with a headphone.
Can you hear me?
Now, yes, can you repeat me?
Yes, so Franco was asking, newspaper use stock photos all the time, which do not correspond necessarily to the current event. It's an old practice. How does this play here nowadays?
Yeah, this is true. This is what I show you before. Sometimes the event is uncorrelated with the image that was with the event itself, no? So what is important is to link these two facts. Nowadays, it's really important. Yes, it's common, it's a common use, but now than ever is more important because the information flow very fast. So it's important to understand if the content is related to an event, and it's important the semantic inside an image. So what we the next the future direction of research now is understanding also the semantic of an image in the context of the news itself. So related to a text, to the image, to a video, and so on. So it's really important, and there is the current research is going in this direction. Okay. So if we go with the presentation again, sorry. Okay. So what we okay. Um, so how to secure an image or a video? There are many techniques. We say digital watermarking, we say blockchain, for example. For example, we can insert image and video inside. We can encapsulate it in a blockchain, and it's the blockchain itself that guarantee the integrity of the media. But there is another field of research that is called image and video forensic that analyze the image from another point of view. With image and video forensic in particular, what is for image and video forensic? It's important to assess the origin and originality of an image or a video. This is the definition. But it's important because image and video in this in this research field is we study image and video as it is. So we don't know the image at the origin, and we don't know anything else about the content. So we study the image as a matrix of pixels. What we want to do is to gather information on the history of the images and the video contents. Because we would like to understand, given final digital images, we know only these images, so we don't know anything else about the process that was employed to acquire these images and to produce these images. So we would like to understand the acquisition process. So, which is the device that acquired this image, and also all the processing that we called out camera processing that are employed to produce these final images, final image. For example, we can think about all the process that can be done through software, photo editing software, video editing software, or social network that can introduce in the image some kind of modification. This is done because this is possible somehow. So to understand each of these steps, because each of these manipulation, this processing, that can be in camera, so inside the acquisition process itself, or out camera, outside the acquisition process, leaves on the media peculiar traces. So these distinctive traces can be exploited, extracted to make an assessment on the content itself. So each phase of this acquisition process can leave distinctive footprints at two levels. At the signal level, as already said, in the matrices of pixel of the image, and also at the metadata file container level. So that means, for example, for a JPEG image, it's possible to understand if an image is modified or not, looking at the EXIF metadata of the JPEG file. But for forensic, for our in our research, in our we don't what we have at disposal. We consider only the image and sometimes the device, but not all the time. So we have at disposal only the image. We don't rely on external information like metadata. because sometimes metadata can be erased, so we don't have this information anymore, and sometimes these metadata can be also tampered with. For example, changing the name of the camera that shoots a certain picture. So all the method in forensics need to be blind, because the original reference media is not required. We don't have the original images at disposal. And is passive because we cannot rely on active methods. For example, digital watermarking, because as before, we don't have the original image where to insert the digital watermarking. So we need to deal only with the final image. That's, for example, a forensic analyst have to analyze at that moment. We don't have any other side information. So the point is to what can be done. So looking on only to an image. We would like to do is to extract a fingerprint of the image, looking for distinctive imprint that was left, for example, during post-processing or during the acquisition processes already inside. So the point is to extract, define this fingerprint, and extract them, and then classify somehow in order to understand from a point of view which is the device that acquired the image, but also to understand if this fingerprint is inconsistent inside the image. So if there are some part of the image where there is a certain kind of fingerprint, but in another part of the image is no more visible, or not the same fingerprint. So this is also an indication that something happened in the image. So image and video forensic is divided in three main branches. It's about source identification. The first branch is about source identification. That means that we would like to link a multimedia content to a particular class of acquisition devices. The second branch is about forgery detection, because we would like to decide on the integrity of the media, so we would like to know if an image is original or not, or is manipulated. The third branch is about adversarial forensic. In this branch, we would like to understand if we have an adversary in front of us. He knows something about the technique that we employ for source identification or forgery detection. We would like to know if the adversary is able to counter us, and also if we are able to understand something about the identification of the source, also about the detection of the forgery, also in the presence of an adversary. So now I would like to talk to you about the main two branches. So the first two, about source identification and forgery detection, I would like to give you some methods, recent or less recent, and then we can talk about it. So if you have some question about this introduction, can you ask me?
Yes, so let's give them maybe 2 minutes to ask questions if there are, and then we'll just 2 minutes, and then we'll continue. Just one thing, Irene, I think you have a hardware problem with your microphone, because the problem keeps happening. It's lower, it's less frequent than before, but you still have the volume going down sometimes.
Mm-mm. I know because I really check a lot because this morning when I tried Zoom, there was this problem too. But I tried to fix it with this with the setting, but I couldn't fix
Uh,
really well.
it might
I'm
be
sorry.
the cable. It might be the cable of the microphone. I don't think it's related to Zoom itself.
But the microphone is the laptop one.
It's the laptop one. Then I don't know. Maybe I don't know.
Maybe it's not a good quality microphone.
Yes. So guys, are there questions? If yes, please post them on the chat right now. Otherwise, we'll move forward. You have still a few seconds to write. Otherwise, we'll move forward. Okay, so we have a question, which is: are these three processes coincident or parallel?
Which one?
I think these three that you have on the slide.
Ah, this one. Ah, okay. No, I think no. It's not a process. It's not a sequence. Each of them can be analyzed first of all independently from each other, and but of course, if you want to do a pipeline, you can do, I think, like this. First of all, we can identify the source, we can detect a forgery, and then we study if there is some kind of adversarial technique that is able to tackle the method that you find for each of them. But in general, these branches are independent from each other. So we study source identification, and this is a macro point, a micro research area. And, and also we study forgery detection. This is also another macro area. It is why I would like to talk you about them independently. So I show you the technique able to say something about the source identification and also about forgery detection, but are other kind of techniques.
Okay, because one comment that we have is: I don't understand well what is meant by forgery detection and adversarial forensics, but you're going to talk about them. Right, so,
Yes.
okay.
Okay. Let's start with the source identification. The source identification is it's simple. It means I have an image and I would like to understand this image, which is the device that acquire that image. So we have three different level of depth of this. It's possible to understand the class of devices. So I have an image, and it's possible to say if was acquired by a scanner, by a smartphone, by a digital camera, and also if it was acquired, was generated by some kind of computer graphic editing software. This is a micro categorization, no? So given an image, I want to understand, oh, it's coming from a smartphone, it's coming from a digital camera, from a scanner, and so on. Other kind of study that we can do on an image is about which kind of brand or model was shooting the image. Shoot the image. So it's possible to understand if an image is coming from a certain brand of a camera, for example, Nikon, Canon, Sony, and so on. And if you are understanding also which is the model related, for example, the brand Nikon, for example. If we want to, if we know that it's coming from Nikon, we would like to understand if, which is the model of Nikon that shooted the image. Can be one of them, Nikon D70 or Nikon D30, for example. But we can go farther. We can understand also the device, the specific the device or that shooted an image. In particular, we can understand if we have more than one camera, for example, with the same brand or model, we can understand which is the specific camera that shoot the picture. The specific serial number. We can go, we can understand which is the camera that shoot an image. And if this camera is belonging to a certain person instead of another person. In particular, how can be done this kind of categorization from the class of the devices, so micro categorization, to a specific classification. So we can understand the specific camera. So this image is coming from a Canon XYZ belonging to a certain person. In particular, we study the acquisition process of a digital camera. Here, there is the acquisition process that is known of a digital camera. The scene go through lenses, they go through different optical filter. There is the color filter array that give the color at the image. There is the image sensor, and so on. All this kind of process. In particular, there are some kind of part of this process give more information about brand and model identification, for example. For example, the color filter array pattern is a characteristic that is specific of a certain model of a camera. Different brand have different CFA pattern. And so also, for example, the in-camera JPEG compression processing can say something about the brand model identification. Regarding device identification, what we look for in the acquisition process is about the image sensor of a digital camera. In particular, the CCD or CMOS sensor of a digital camera have some information that we are able, if we are able to exploit this information, we can understand what is the camera that shoots the image with no more doubt. Let's go in detail on this, because this is one of the first image forensic technique that is very well established, was used also in some trials in US because it's quite reliable. In particular, we look for this imperfection in the CCD sensor of a digital camera. In particular, we look at this noise that we call photoresponse non-uniformity noise in forensic, that is caused by the different sensitivity of the sensor to the light, and is due to the manufacturing process. So it's due from the silicon buffer during the construction of a digital camera. One of the property of this noise is that does not depend on temperature and time. So it's independent on time. So this is why it's a good fingerprint, because doesn't vary in time, and also the temperature that maybe a digital camera can be affected by different temperature during its life, but this noise is not changing in time, and also with changing temperature. So if we are able to capture this noise, we can create a link between a camera and a picture that this camera shoots. How can be done this? It's possible to build a model of this PRNU fingerprint. In particular, if we have a digital image I taken from a certain camera C, the model of the camera can be, of the image, can be written in this way, where we have the acquired image I prime that is equal to the denoise image, so the image without any kind of noise, so the perfect image, plus some kind of other noise term, giving from the shot noise without noise from the camera. And also from this kind of term that is given, that is the PRNU fingerprint, is the contribution of the noise in the final image given by the PRNU fingerprint. The PRNU fingerprint, it's interesting because it's possible to estimate this fingerprint from, I don't know, I can say 10, 20 images from a camera. So it's not really complicated to estimate it. It's better if these images could be uniform images, so blue sky or I don't know, some uniform surface, but we can estimate this noise also from images with content. So it's kind of easy to estimate this K. In fact, can be the estimation is this one that I report here in this slide, but is only a summation on the n images that we want to take in account for the estimation. For example, the 10 or 20 images that we want to use. Here there is a multiplication of the image itself, so the acquired image, by the contribution of the noise. So the acquired image minus the noised one, using some kind of filtering, image filtering. In particular, for PRNU extraction, we use some kind of wavelet fingerprint. And the estimation is done averaging on all the images used for the estimation. This is used to suppress all the content that the image can have inside. And in this way, we can have in K, that is the fingerprint estimation, only the noise, so only the PRNU fingerprint. Okay, so this is the extraction. For the detection, it's really easy because we have an input image that is Y, for example. We would like to understand if this image Y is coming from the same camera C that I calculated the fingerprint before, or another one. So the presence of K in Y can be determined by a correlation detector. This correlation detector is simply a correlation between the residual noise of the image Y, that is this one, this part, this one, this is the noise of the image Y, the correlation of this term with the reference fingerprinting multiplied by the input image Y. So this is really simple. So if this correlation is high, of course, over some kind of threshold, if you want to I don't know, we can fix the false positive rate a certain value, and then we can fix a threshold. So if this term is high, is over a certain threshold, right only if Y is acquired by a camera C with a certain PRNU K. Otherwise, this term, this raw, this correlation is null. And so it's possible to understand and to link if the image Y is related to a certain camera C or otherwise. This is the point. The analogy is very straightforward. What we want to know is the same as what we done with firearm identification, because the camera, in particular the sensor of the camera, is like the bullet of a gun, where when the bullet of a gun is shooted by a gun, is superimposed, the scratches can be superimposed in the bullet, and so it's possible to understand which is the gun that shooted a certain bullet. It is the same in digital camera. If we find in the image a certain noise that is related to a certain camera, so it's possible to understand that this image is shooted by a certain camera KT. Do you have some question about this? Otherwise, I can go.
So there is one question, which is, are these methods used nowadays? I mean, it's more related to what you were saying before, probably, but are these methods used nowadays, or they are still experimental? I mean, is this being considered, or before publishing, for example, by the press, or what? Like all of what you just said.
Yeah, the method is a research method, of course, but was used, and it's used in the trial in a court of law. I don't remember some years ago, especially in US. There was this trial about understanding which is the digital camera that shot an image, and was recognized as a method that is able to do this also in a trial. So was a method that it works. So
Okay. So, do you want to do a short break now or later?
okay, we can do a break now.
Okay, so let's do a break now. 10 minutes break, guys. We're going to leave the stream open again, and as usual, I'll just ask you to answer the usual. Usual. It's the second time we do it. The question for attendance, and I'm publishing in the chat the code that you need to use. That's it. So let's have a 10 minutes break then. Okay. Okay, so we are back. We have three questions. First of all, we have to estimate k, we need to use w equals I prime minus if, you said. What is or how do we compute if?
I have this one.
You're not sharing your screen.
Ah, okay. So I'm changing by myself, but not in the slide. This one. Okay. This IF.
You're
Is
still not sharing the screen.
no?
No.
Ah. Sorry about this.
No, we see you, but we don't see the screen.
How? I'm sorry. Oh, now?
Yes, we do see the screen now.
Okay. The question was about this formula, and this Wy is is I prime minus IF. This IF is the noise of the is the image filtered by some kind of filter that is able to extract the denoised version of an image. So this is the formula for IF. Is the I prime, that is the acquired image, with some filter applied to this image that is somehow equal to the denoised image. So the image without any kind of noise. And it's possible to calculate this with different filtering operation, Gaussian filtering, median filtering, but for this task is used the wavelet, a certain kind of wavelet filtering. Hopefully I can.
Okay, thank you. So we have we have two more questions. One is there an already existing database for the various cameras, peer and new?
As I said, no, in public PRNU database are not existent for public access. From a point of view of research, there are a lot of databases, but more for more with images, not with PRNU already extracted. So there are databases with different images coming from different devices. We know which kind of device shoot the images, but there isn't the PRNU already extracted.
Okay, okay, quindi. So one last question that we have is, what if the source is computer graphics? What happens in that case?
With this method, actually, if the source is computer graphic, you cannot establish a correlation with any. For example, if we have a data set with different camera, where we have a different fingerprint for each of these camera. If you have an image, a test image that is coming from computer graphic, it's not possible to associate this image with any kind of fingerprint in the database. So this correlation here, if I can, okay. This correlation here remain low, certain threshold. So it's not possible to associate that image coming from a computer graphic with a certain fingerprint K. Hopefully I could answer to all the questions. Okay, so I can go further with the presentation. I would like to introduce you another point that is social network identification, because in general, as I already told you about before, source identification is the process to link a content with a device. But lately, we also are interested in establishing the social network of origin of a certain content, multimedia content. So we would like to understand if a certain image is coming from a certain social network, for example, Facebook, Twitter, and so on, or some kind of instant messaging application like WhatsApp or Telegram. Why this is important? Because social network are channels that are able to distribute multimedia content in an uncontrolled way. So image share are really quick, and so sometimes it's not easy to follow the path that a certain content, image content, follow in various social networks. From a forensic scenario, so when we have to deal with an investigation, it can be strategic understanding this flow, this path that an image is taken, revealing all the steps followed by certain content. This is done in the same way. The process that we apply is the same, because we would like to understand if each social network applies specific traces in the image that is and these traces are particularly related to a certain social network. This is really important if you understand, if you think about it, all the pedopornography phenomena on the web, because it's important to understand if a certain video, pedopornography video, was shared from a certain social network, and in particular from a certain user or group of users. The idea behind this is that, of course, that uploading an image on a social network alter an image from a different point of view, because the image is resized, because the image I'm not what happened? What happened? I don't understand, because you cannot see my presentation. Can you? Ah.
Problem. Actually, we also have a couple of questions if you want to take them now.
Now I think there's this problem again. Sorry about it.
No.
It's not easy, guys. I'm sorry. Now it's
So
working.
now we don't see the screen at all. We see we see nothing.
Okay. Maybe.
Okay, yeah. Now that's working.
Okay, now it's beginning, so I have to.
It's working.
Okay, you can go with the question if you want. Now.
Yeah. Okay. So we have a few of them. One is if it is possible to remove a PRNU from an image.
Okay, this is a good question. This is an adversary things because if you are able to extract the fingerprint from an image, of course, from a bunch of images, it's possible also to remove, but it's possible also to do something more. That means replace another fingerprint from another camera and put in another image coming from a different camera. Of course, all of them are possible attacks. Of course, this method can be fooled, but there are other methods that are able to understand if something has been done in the image. And so it's possible somehow to understand if these attacks are was done or not.
Okay, thank you. So we have other questions, which is so if we have understood well, PRNU is different for every device, like a human fingerprint. So there cannot be a database. This is more a comment. So there was some discussion on the chat. I'm going to read that.
Okay, good.
Um, the other guy replied, if we know that there is some noise that depends on the camera inside an image, can we remove it intentionally? So I think this can be also a question that you can answer, which is related to what you were saying before. So you already answered.
Mhm.
The other question is this method also used with devices that use multiple cameras like iPhone X or Samsung Note 10?
This is also a good question. Yeah, no, there are not research work on this topic yet, and can be really interesting to start some some research also on this topic on multiple camera fingerprinting. Actually, I was discussing this a couple of months ago with some professor in Padova. We were discussing just of this kind of problem. It's really really interesting. But at this moment, there are not method able to do this. So thanks for the question. It's really go to the point.
Okay, so we have one last question, which is what kind of problems will have the identification process of a video with a different resolution and frame frequency taken by a digital camera?
Yes, for the video, as you can imagine, it's more difficult to extract this fingerprinting. This fingerprint, especially because the video frame, the content of the video frame, it's the same most of the time, especially if the video is not really in movement. We don't have many movement in the video, so the extraction is more difficult, and this method is not working really well. This method is working really well for digital camera, of course, not multiple camera. Was working really well until this new smartphone came out. Let's see something like this. Okay. So regarding this new topic about social network identification, we talk about the kind of processing that. Okay. Okay.
So yeah, there is one last question, which is, does compression on the image affect the PRNU?
Of course, of course. Yes, compression affect a lot PRNU, and also if you don't acquire the image at the full resolution of the sensors. this is also the point. Also, if you resize the image, can be a problem. But there is also other kind of work that try to overcome this kind of problem, and it's kind of robust also to JPEG compression and resizing. But of course, you can understand that is not easy. Okay, so okay, let's go with the presentation. We have a lot of things to do. Okay, regarding social network, the idea is to identify the social network where an image is uploaded, and so this can be done resorting by these traces, can be imprinted by the social network in the content during the upload-download process by every specific social network. The idea, this is a work that I done a couple of years ago during my fellowship in Australia. The idea is to resort to a different feature. One is related to image content, to intercept processing like JPEG multiple compression, because of course when an image is uploaded on a social network, it is recompressed, can be resized. So we would like to extract feature also regarding this point, and can be also filtered, can be applied some kind of filter by the social network. On the other side is to use the feature coming from the metadata, because we would like to take account also changes to the characteristic of the image file, quantization table, image size, also the name of the file, and so on. So the idea regarding the image content is to study the histogram of DCT coefficient. DCT is the discrete cosine transform of an image that is used for the JPEG compression in the JPEG compression algorithm. This histogram allows the distinctiveness among social network. If you can see from this graph, for example, later I'll explain you how this histogram is computed. But from this graph, you can understand what is the point. This one is the histogram for Facebook, the red one. This one is the histogram computed for an image coming from Twitter. The same image that was uploaded on Facebook, on Twitter, and on Flickr. This is the histogram related to each of these images. And you can see also with your eyes that these histograms are